All right, welcome everyone to today's Explainer. I'm absolutely thrilled to have you here. So today we are putting on our structural consultant hats, and I'm talking directly to you, the junior site engineers and project managers who are literally out there on the ground. We're looking at a truly crucial intersection in our industry, the structural parameters of the materials we use and the geographical reality of where we actually build. Specifically, we're diving into official structural data and geographical hazard compliance across India. If you're managing builds, overseeing reinforcement layouts, or signing off on site documentation, the data we're about to cover is your absolute baseline for safety and compliance. Let's get started.
Here's a quick look at our agenda. We're covering 1. Structural steel categories, 2. Multi-hazard districts overview, 3. Eastern hazard zones, 4. Northern hazard zones, 5. Our high-density hazard zone, and 6. Building documentation.
Okay, Section 1. Structural steel reinforcement categories.
When you're verifying reinforcement layouts on site, I want you to use a simple analogy. Think of concrete as a building's muscle to handle squeezing, and steel as its bones to handle bending and stretching. Now, without compression steel, we rely purely on variable A to handle tension. But when heavy load effects demand compression steel, we have to track our H, B, and Y variables. And the difference in how these fail is massive. If a section without compression steel fails, you'll see large cracks forming at the bottom as the material stretches. But if compression steel fails, usually due to overloading or really common installation errors like improper spacing or inadequate concrete cover, you will witness explosive spalling. That's where chunks of concrete violently break off, and you can physically see the steel rebars buckling. It's a nightmare scenario. Identifying these variables isn't just textbook theory. It's about preventing catastrophic buckling on your watch. And yes, a reinforced beam section does have a higher upfront material cost compared to a non-reinforced one, but honestly, that cost is pennies compared to the millions it takes to deal with a structural collapse.
Moving right along to Section 2, Multi-hazard-prone districts overview.
So, this is Annex M, Table 6.1. This is essentially your definitive go-to guide for understanding which regions face overlapping geographical threats, whether that's seismic activity, high winds, or other regional hazards. When your build is located in one of these districts, your structural parameters, like that compression steel we just talked about, must strictly adhere to the hazard codes. No exceptions. And if you look at the raw data output here, it reveals a massive sweeping list of districts across multiple states. Multi-hazard compliance isn't just some niche scenario you'll run into once in a blue moon. It's a widespread reality across India. Let's see how this actually builds out regionally, starting over in the east.
Section 3. Eastern hazard zones, focusing on Assam and Bihar.
Check this out. Assam's multi-hazard districts span basically the entire state, from Barpeta all the way to Tinsukia. Operating in major hubs like Kamrup or Jorhat means your site is sitting directly in a high-risk seismic zone safety corridor. The ground forces here dictate that those structural steel variables, H, B, Y, or A, require absolute precision. Let me give you a real-world site scenario. Misaligning your reinforcement bindings during a hectic concrete pour. It happens all the time, right? Well, in these zones, that common installation error severely compromises the structure's seismic resilience. You literally cannot afford that mistake here.
Over in Bihar, the hazard distribution is equally staggering. Major development centers like Patna, Muzaffarpur, and Bhagalpur sit right in the crosshairs of overlapping hazards. If your site is in Darbhanga, for example, your material load capacities are entirely dictated by these aggressive multi-hazard realities.
All right, Section 4, Northern hazard zones, covering Haryana and Punjab.
Haryana's list includes incredibly developed urban centers like Gurugram and Faridabad. The immense scale of commercial construction happening in these hubs sits squarely within multi-hazard terrain. What does that mean for you? It means every single high-rise build requires meticulous, constant attention to those compression steel load variables to ensure long-term stability.
And Punjab features 12 distinct hazard-prone districts, including major industrial centers like Ludhiana and Jalandhar. So whether you are working on a commercial high-rise or a massive industrial complex, you are legally mandated to build to withstand these specific documented regional load effects.
Moving to Section 5, High-density hazard zone, which includes UP and Uttarakhand.
Just look at the sheer volume of districts across UP and Uttarakhand. This requires monumental compliance, spanning incredibly diverse terrain from the plains right up to the foothills. Operating anywhere within this dense list means multi-hazard compliance is your daily baseline. It also means that routine maintenance steps are absolutely vital.
We're talking about scheduling regular non-destructive testing on concrete structures, especially post-seismic events, to continually verify that the embedded reinforcement integrity is actually holding up over the decades.
Finally, Section 6, Building Documentation and Verification on Site.
Now, official building address requirements might look like standard administrative paperwork to you. Actually, scratch that. A lot of people treat it like an annoying formality, but it is absolutely your primary compliance tool. This exact form is how authorities verify that the correct, rigorous structural codes are being applied to your precise geographical hazard zone.
You should treat this form as your site engineer's ultimate checklist. Beyond the basic building name, plot, and town planning details, the district is the linchpin of the whole shebang. Writing Lucknow in Box 5 legally binds your project to Table 61 standards. On site, this paperwork has to be matched by a rigorous physical checklist. You need to be actively verifying your reinforcement layout on site, checking for proper concrete cover, and making absolutely sure the correct steel grade is used before a single drop of concrete is poured.
So, what does this all mean for you? It brings us to the ultimate question for your site today. Is your documentation genuinely ready for multi-hazard zone compliance? Are you meticulously verifying those HB and Y reinforcement layouts out in the field? Because you have to remember, the cost of cutting corners isn't just a failed building inspection. The real cost is the physical failure of overloaded beams, the explosive concrete spalling, and severely compromised safety for anyone using that building. Take these insights to your site today. Keep learning, keep verifying, and stay focused out there.